Good morning, friends. Today we are going to do some numerical problems of Chapter 6 Physics, Class 9 book, ICSE, Pressure in Fluids and Atmospheric Pressure. One of the basic problems before you go deep into the numericals of pressure in fluids is about pressure. Like, what is the relationship between pressure, area, and the force? So the problem states here is a hammer exerts a force of 1.5 Newton on each of two nails A and B. Okay, so we'll draw two nails. One we will mark as A, another nail we'll mark as B. I use two colors so that we can differentiate between two nails. So let's draw nail A. Nail A looks something like this, and nail B will look something like this. You might think why nails are normally pointed, why I have made this bottom of the nails a little blurred. That's because the area of cross section of the tip, this is the tip, this point is the tip of the nails, this is the tip of the nails. For nail A is 2 millimeter, so this is 2 millimeter square. Okay, area is millimeter square, that's the unit of the area. For nail B it is given as 6 millimeter square. So you can clearly understand that though nails looks very pointed, if you use a microscope and go really deep into it, you can see this is not totally pointed. Like, points are also made of with smaller points, so that is, it gives an area. Just to make you understand, this area is more than this, I have increased the area of nail B. Now it is acted on a hammer with a pressure. So let's draw two hammer, or this is one hammer on nail A, and this is the same hammer on nail B. Both the force are what? 1.5 Newton. This is also 1.5 Newton. Okay, so both the force are same, but they are asking for the pressures on each nails. Like, will the pressure be different? Let's see why it is different and how it is different. So we know that the formula for pressure is nothing but pressure is equal to force acted on unit area, that is numerically or mathematically pressure P is equal to force F by area A. Now here the force are same, so normally the pressure should be same, but the area of nail A is different than area of nail B. So if the areas are different, obviously the resultant pressure will be different, because the numerator is the same but the denominator varies. So if the denominator varies, the resultant P will also vary. Now let's see, the force is given in Newton but the area is given in millimeter square. So we need to convert millimeter square into meter square. We all know, since our childhood we have learned that 1 meter is equal to 1000 millimeter, okay, or 10 to the power 3 millimeter. So if you use square, so 1 meter square is 10 to the power 3 into 10 to the power 3. That is, for indices we have learned that the powers gets added up. Okay, so 10 to the power 3 into 10 to the power 3 will be nothing but 10 to the power 3 plus 3, that is 10 to the power 6 millimeter square. Why are you converting millimeter square to meter square? Because for numerical formula, force, if the force has to come in Pascal, that you have force, sorry, if the pressure has to come in Pascal, the force have to be in Newton and area have to be in meter square. So 1 millimeter square is equal to nothing but 1 by 10 to the power 6 meter square, which if you use indices, we'll write 10 to the power minus 6 meter square. So Now for nail A, we'll go to the next page and try to do nail A. For nail A, the pressure is equal to force, that is 1.5 Newton. I will write the unit so that you will remember. Divided by how much? What was the area given? The area was given 2 millimeters square. But 2 millimeters square is nothing but 2 into 10 to the power minus 6 meter square. We have converted everything in SI units. 2 into 10 to the power minus 6 meter square. So we can put 10 to the power minus 6 is goes to the top, that it becomes 1.5 into 10 to the power 6. Just indices that you have learned by 2. Now to make your things easier, if I use 110 out here from this 10 to the power 6, if I take 1 like 10 into 10 to the power 5 and multiply that with 1.5, that is giving 15 by 2 into 10 to the power 5. Now 15 by 2 is, we know how much is 15 by 2. If you don't know, we'll just divide it for you. 2, it gives how many times? 7 times, so it becomes 14, and we have 1, we have nothing to put in, so it becomes a point out here. We can put 0, so 2 5 0 10, so it cancels out. So that is nothing but 7.5 into 10 to the power 5. What is it? Newton per meter square. What is that? Pascals. That's Pascal. Okay, so the pressure is 7.5 into 10 to the power 5 Pascal for nail A. What happens to nail B? We have used red color for nail B. So for pressure in nail B, again the things are very same. 1.5 divided by, what was the area of nail B? The area of nail B was 6 millimeter. That is 6 into 10 to the power minus 6 meter square. So now we can do it. 6 into 10 to the power minus 6, and which is nothing but it is equal to 1.5 like we have done. And law of indices, if it goes up, the sign changes by 6. Now we again use 110 out of 10 to the power 6 and keep 10 to the power 5 out there, so that we can make it 15 into 10 to the power 5 divided by 6. Now we can try to get it in the lowest form, so we can cut it by 3. Yeah, 3 is common both for 15 and 6, so you get 2 here and you get 5 here. So we get 5 into 10 to the power 5 divided by 2. Now 5 by 2 is easy to do. Half of 5 is nothing but 2.5. If you don't know, we'll again do it for you. So that's go for 2, so that's 4 out here. So you have 1 in remainder, you put a decimal out here, and then we add 0, so that will become 5, so it's 10. So it is nothing but 2.5 into 10 to the power 5 pascals. Remember the unit. So pressure on nail B is 2.5 into 10 to the power 5 pascals. Now we can understand one thing, that the pressure on nail B is less because the area is more. How much less? 3 times less. This was 7.5. If we divide 7.5 by 3, we get 2.5. Why it is 3 times less? Because the only reason, because this is 3 times more. The area is 3 times more. That's why the pressure is 3 times less. So as the area becomes bigger, the pressure becomes lesser. Okay, that's why if you are using a blunt pencil to put it on your hand, you will not feel that pressure. But if you're in a sharp pencil to put it on your hand, and you'll really feel the pressure. The force remaining the same, but you can feel it hurts us because the area is less. Even with the same force, we feel the higher pressure. So thank you, and we will come with more problems regarding all of your chapters of physics, so that it will help you to prepare for your exams. Thank you. Bye bye.